So today we learning how to find the rule from the graph. How to find the rule from the graph. And let's consider it on the, let's say, example 2 from your booklet, which is on the page page 30, sorry, 29. Example 2 on the page 29. So we have a graph, we have given graph, and we will need to identify its rule. We have asymptote x equals -3, and we have another asymptote y equals 5, and we have the graph looks like this, and we have the y-intercept 0 and 7 and 2/9. Let's change it to 65/9. I prefer always when it's in proper fraction instead. And we need to identify the rule for this graph. First of all, what type of graph it is? Truncus. So we have the general equation of the truncus will be y equals a divided by x minus h squared plus k. That will be the equation that we're looking for. We just need to identify h, k, and a. What we can identify from the graph straight away?
K is 5.
We can say that k equals 5 because that is y asymptote, that is the horizontal asymptote, and we can say that h equals 3. So we're already just looking on the graph from the asymptotes, we can say that it's a over x minus 3 squared plus 5. To find a,
Solving the point 0. Double negative.
x equals -3, so x plus 3, x plus 3 squared plus 5. So we need, how we can identify the a? Substitute the point x equals 0, so we have y is 65/9. 65/9 equals a divided by 9, x is 0, 3 squared is 9, plus 5, so we have a over 9 will be equal 20/9, 65 minus 9, 20/9, so a equals 20. So we have identified the equation of this graph. Make sense?
Yes.
Another example. It's asking for domain and range, so that we can state from the graph that what will be domain.
X is an element of real except -3.
Yes?
Yeah, go on.
X
That's right.
is can be all real numbers except -3. X can be anything except that -3. And y greater than 5, so range is from 5 not including to infinity. That we can read just from the graph straight away. Another example that we will do will be from the let's say example 5. Example 5, we have another graph which we need to find the root.
Exactly.
So we have the graph. Yx, we have starting point negative 2, 2, and we have one more point on the graph 1, negative 1, and we need to identify the equation of this graph. First of all, what graph is that? The square root graph. So we have y equal a times square root of x minus h. Oh, don't keep breaking. Where a x minus h plus k. And so, again, looking on the starting point, what are the h and k coordinates?
H is negative 2 and
H equal negative 2, k equal positive 2.
Yes, sir.
Does everyone understand why?
Because it's like this and like this.
Hmm?
It's like what?
Because those are starting h and k.
No, H is 2,
H is
H is 2.
2, that's all I was saying.
It's X minus H.
Yeah, X plus 2.
Okay, let's check if
But still equal negative.
Yeah.
Ellie, if we take x equals 2, if you take h equals 2, we take x equals negative
X
2.
minus, oh, yeah, right.
You don't
Wait,
need to
so,
Stop.
yeah.
Let's clarify
No,
this.
that's right, that's right.
Let's clarify this. If we take k equals 2, everyone agreed that k equals.
No, I meant X, it's X plus 2, but yes, you're right. Like,
It's
it's
X
A
plus
root X
2,
plus
but
2.
all
Yeah,
Yeah,
that's what I meant.
it is x plus 2 because minus minus will be
Exactly.
plus.
Yes.
Yes.
Exactly.
So we already identified that this graph is y equal a square root x plus 2
Yes.
plus 2. Now to find a,
Yes.
we substitute given point. So we have negative 1 equal a square root of 1 plus 2 plus 2. So we will have that negative 3 equals a root 3. So a equals negative 3 divided by root 3 or equal negative root 3. So a equal negative root 3. So we have that final equation y equal negative root 3 times root of x plus 2 plus 2. We can take this inside this square root, but we don't have to. We can take these 3 inside. That will make the equation negative square root 3 times x plus 2 plus 2. Because square root times square root, we multiply the expressions under square root. Both answers will be correct. Make sense?
Yeah.
So, what are the steps of identifying the root? First, we identify what type of the relationship it is. Either it is a parabola, or sideways parabola, or it's hyperbola, or it's truncus, or it's square root. As soon as we identified it, we can, using asymptotes for hyperbola and truncus, or starting point for the square root graph, you can identify the translations, horizontal and vertical translations. After that, we will have, always will have extra point It can be x or y-intercept, or can be just some random point, like in this example. We substitute it in our rule, and we find the remaining, the dilation factor. Make sense?
Yeah.
Okay, that's the last bit of this topic. Like, subscribe, and donate to help fight terrorist countries and organizations.